Arkadaşlar yeniden merhabalar. Şimdi dersimizi başlattık. Ee, Şimdi ekran kaydını da aktif hale getireceğim. Şu anda ekranımı görebiliyor olmanız lazım. Bir problem varsa lütfen söyleyin. Yok herhalde. Şimdi geçen hafta, daha doğrusu son dersimizde yaptığımız temel iş neydi? Nesne önemli programlamada kalıtım başlığını işlemiştik. Ve kalıtımın ne demek olduğu, yani inheritance konseptinden bahsetmiştik ve inheritance konseptiyle ilgili dikkat etmemiz gereken hususlardan bahsetmiştik. Inheritance kavramı özet anlamıyla ne ifade ediyordu bize? Esas olarak bizim bir hali hazırda yazılmış olan bir sınıftan yeni bir sınıf üretmemizi sağlayan bir teknikti, nesnelerini programlama dili altında geliştirilmiş olan. Bunu yaparken de belli başlı dikkat edilmemiz gereken hususlar, halihazırda yazılmış olan sınıfın hangi özelliklerini, hangi şartlar altında kullanabildiğimiz ve bunu yaparken ne gibi tekniklerden faydalandığımız. Mesela method overriding denilen bir teknikten bahsetmiştik. Ne anlama geliyordu? Halihazırda olan bir sınıf içinde tanımlanmış fonksiyonu biz yeniden tanımlanmasını alt sınıfta şekillendirmemizi sağlayan teknik. Yani burada da bu metodun metod signature'ını bozmadan esas ise body'sinde yaptığımız modifikasyonlardan bahsediyoruz. Ve benim parent child class ilişkisi ya da subclass super class ilişkisi neydi? Bunun üzerine konuştuk. Ve burada da aslında nesnenin programlama sınıf class design'ındaki iki temel ilişki düzeyinden bahsetmiştik. Bunlardan bir tanesi is a relationship ve has a relationship. Is a relationship, yani mesela A sınıfı B sınıfının alt sınıfıdır gibi bir ifade kullanmak istediğimiz ya da bizim derste yaptığımız örnekte ne demiştik? Bir araba aynı zamanda bir araçtır. Vehicle, car örneği vermiştik. Bunlar is a relationship örnekti. Bir sınıfın başka bir sınıftan nesne barındırma durumunda has a relationship olarak adlandırmıştık. Bu kavramları bu hafta itibariyle de işlemeye devam edeceğiz ve öğrendiğimiz yeni konseptleri yeni başlıklarla ekleyeceğiz burada. Bunun için de iki temel esas konumuz olacak. Bunların birincisi interface, diğeri de abstract class kavramları olacak. Ve interface ve abstract class kavramlarıyla aslında bir sonraki aşamada göreceğimiz polimorfizm, yani çok formluluk kavramı üzerine ilerleyeceğiz. Şimdi inheritance konseptinden bahsederken getirdiği iki temel avantaj olduğundan söylemiştik. Bunlardan biri code reuse. Yani halihazırda sınıfın içinde bir yazılmış kod bloklarını sadece çağırarak kullanabilme yetisi kazanmamız durumu. Bir de substitution principle diye bir şeyden bahsetmiştik. Üst sınıftan bir nesne beklenirken o değişkene, üst sınıftan bir nesne tutması beklenen bir değişkene o sınıfı bir alt sınıfından nesne atayabilme yetimizden bahsetmiştik. Zaten substitution principle bizim göreceğimiz üzere bizi polimorfizm denilen çok formlu konseptine doğru ilerletecek. Tabi şimdi bu bir hiyerarşi kurduğumuzu düşünürsek ki yaptığımız esas itibariyle bu. Bu hiyerarşik düzende bize belli başlı esneklikler gerekiyor. Aslına bakarsanız bir proje geliştirirken. Bunu şöyle bir örnekle açıklayalım. Biz bir bilgisayar oyunu tasarlamak istiyoruz. Bilgisayar oyunumuzun içinde ilk başta tasarlarken iki temel karakter tipi var. Bu iki karakter tipinin birbirleriyle ortak özellikler barındırmasıyla beraber kendilerine has durumları da söz konusu. Böyle bir hikaye söz varsa elimizde, yapacağım temel yaklaşım şu olacaktır. Karakterlerin ortak bulundurdukları özellikleri tek bir sınıf içinde toplarım. Ve diğer bu iki çeşit özel karakteri bu sınıftan türeterek tekrar iki ayrı sınıf için tekrarlayan metotlar veya data field'ları yaratmak yerine ya da instance variable diğer adlarıyla bunları bir kere yapmış olurum ve code reuse'u gerçekleştirmiş olurum aslında kalıtımla o ata sınıfı çağırarak. Bunun bir diğer avantajı da şudur. Oyunda iki tip karakterle başladık. Peki, üçüncü tipte yeni bir karakter oyuna eklemek istediğim zaman bu koşulda ne yapacağım? Bu yeni karakter de aynı zamanda bu ortak özellikleri barındıracak ama kendine has özellikleri de olacak. Demin bahsettiğim bu ana karakterlerin bir temel özellikleri ve diğer karakterlere ondan türetme yaklaşımı işte bizi kullandığımız yani esas itibariyle kalıtım kavramı yine avantaj bize sağlıyor. Çünkü yeni yaratacağım sınıfı da yine esas belirlediğim parent class'tan türetip o çerçevede şekillendirmeme olanak sağlayacak. Böylece benim normalde oyuncu karakterleri üzerine gönderdiğim komutlar klavye veya komut vasıtasıyla yeni sınıfta yeniden tanımlanmak zorunda da olmayacak. Normalde klavye ve benim mouse'la gönderdiğim komutlar aslında bir karakter nesnesi üzerinde çalışabilme yetisi var. Ve bu ne demek oluyor? Aynı zamanda onun karakter sınıfından üreteceğim bütün alt sınıflarda da bu metotların çalışabilme yetisi olduğunu söylüyor. Yani oyunuma yeni eklemeler yapmaya çalışırken aynı zamanda oyunda bozmama gerek yok. Yani yapacağım ek halihazırdaki kod yapısını bozmamış olacak. Bu da aslında neden kaynaklı? İşte bu substitution principle. Normalde parent class'tan bir nesne üzerinde çalışacak bir metot varsa benim klavye veya mouse'tan girdiğim komut üzerine onun alt türlerin hepsinde de çalışmaya devam edecek. Bu bir yerde de bizi yine polimorfizm kavramına götürecek. Bunlarla beraber dersimizin en sonundaki son dersimizde şundan bahsetmiştik. Ne dedik? Multiple inheritance denilen bir konseptten yani çoklu kalıtım konseptinden bahsetmiştik. Çoklu kalıtım konseptindeki temel amacımız neydi bizim? Bir sınıfı birden çok sınıftan türetebilmek. Yani ne yapıyorduk? Class A extends B, class B virgül class C gibi bir yapı yaratabiliyor muyum sorusuna cevap arıyordu. Bu da şu cevabı elde etmişti. Java çoklu kalıtıma izin vermiyor ve bunun da sebebi asas itibariyle yeni üretmek istediğimiz sınıf eğer birden çok sınıftan üretilir ve bu sınıflar aynı isimlere sahip ve değişkenler, data field instance variable'lar veya metotlar veya hatta diyelim barındırıyorsa hangisini ben kalıtım olarak alacağım sorusuna direkt bir cevap Java compiler sağlayamadığı için bu yasaklanmıştır. Buna izin veren farklı diller olduğundan da bahsetmiştik. Mesela Python bunlardan biri. Mesela C# bunlardan biri. Ki bunlar da günümüzde sıklıkla kullanılan diller. Ne kadar bu bir esneklik gibi gözükse de aynı zamanda bir dezavantajı var. O da getireceği karışıklık. İşte bu getirebileceği karışıklıkların sağlayacağı avantajlara daha ağır bastığını düşünerek Java geliştirilirken değil, bu çoklu kalıtım izin verilmemiştir. Lakin bunun bir arka taraftan dolanma yolu da bizlere sunulmuştur. Bu da nedir? Interface denilen kavram. Bir arayüz, Türkçe kelime transferi olan interface kavramı karşımıza gelecek. Bir nevi çoklu kalıtım üretmemizi sağlayacak yapı bu olacak. Ve bir de abstract class kavramından yine bahsedeceğiz bugün. Neden gerekli olabileceğini de konuşmaya çalışacağız. Bakalım interface kavramı neymiş? İnceleyerek dersimize bir giriş yapalım. The Java interface is a collection of abstract methods and the constants. And what is an abstract method means? Which is a method header without a method body. Exactly, when I say that an abstract method, you should understand that a method without a body. Okay, that's the whole thing that you need to consider. But you need to ask, why should I have an abstract method? sözde method. An abstract method can be declared using the modifier abstract, but because all methods in an interface are abstract, usually it is left off. An interface is used to establish a set of methods that a class will implement. Actually, I know that these two definitions are not clear to you right now, and I'm going to make a very simple example which demonstrates the power of the interface. And at this step, you just need to consider two definitions given here, which are the first two bullets here. A Java interface, when I say the interface, you just need to understand a collection of abstract methods and a constants. And then when I say the abstract method, you just need to know is a method declaration, just a method signature exactly. You declare the name of the method, return type of the method, and the parameters of the methods, and then that's all. And you leave the responsibility of the definition of given body of the method to the implementer of this interface that you work on. And okay, and you will ask the following question: why do I need an interface concept? This is just a method naming the function, and that's all. And exactly one of the reasons is given here. The interfaces offer a capability requiring that unrelated classes implement a set of common methods. And this is a very important feature in object-oriented programming, and which is very flexible feature of this methodology. And second one, the interfaces define and standardize the way in which the things such as people and system can interact with one another. Let us look at some examples. Example, the controls on radio circuits as an interface between radio users and the radio's internal components, and which can perform only a limited set of operations, such as the radio controller allow you to change the station, adjust the volume, or choose between AM and FM. But you don't know how the internal this mechanism works, how the station is changed, how the volume is adjusted behind the scene. Exactly, you just turn some button in front of the interface control panel, and then you get the result. And different radios may implement the control in different ways, such as using push buttons, dials, voice commands. And this is daily life example exactly. And in short, the interfaces specifies what operations a radio must permit users to perform, but does not specify how the operations are performed. And again, a Java interface describes a set of methods that can be called on an object. And if I turn back the previous slide, it is written here that interfaces offer a capability requiring that unrelated classes implement a set of common methods. In the first step, we are going to look at this point. What does it mean exactly? Let me open a draw.io firstly. Okay, suppose that we have two classes, say that. We have a class with a name, say that a human. Someone try to enter the course. And then, on the other hand, we have one unrelated classes called as dog. And then we want to make that the human and dog share some common properties, but they are different kind of objects exactly. Also in real life, we cannot treat this both objects in a similar fashion. But we all know that the human and dog can swim and also they can run. These are the common things that between a human and dog. And how can I define that human and dog are both swimmable and runnable objects? In that sense, to define the common properties for those two types, which are exactly two different kind of object concepts, what we are doing is that we define an interface, such as say that give a name to your interface and call this swimmable. And then we all know that both of these objects, exactly human and dog, are swimmable characters. Sorry. And let me find the arrow. Sorry. And to demonstrate the relation between this interface and a human, exactly, we use another kind of arrow. And let me choose the arrow firstly. And we represent the relation between an interface and a class using dashed line. An arrow with dashed line. And the head of the arrow is also the empty one, like this one. And the line is like this way, and dashed line. And this arrow has a special meaning, which is represent a relation between a class and an interface, which is kind of an inheritance relationship, as you can guess. But this is not exactly an inheritance. We just, by stating this, the humans is a kind of swimmable object, which state that we are responsible to implement all the abstract methods within the swimmable interface. This is a kind of agreement between a class and an interface. And in a similar way, we can define that dog is also another swimmable object. And then, suppose that we have another interface. Say that this is a talker, and call that the name of the interface is a talker. And I know that while human can talk and and dog cannot. And if that is the case, I will also define my human also as a talker. And as you can guess, we are implementing two different interfaces on the human class. Actually, we learned that and we mentioned that we cannot extend, we cannot inherit properties of both class in subclass at the same time. But in the case of the interfaces, a class can implement more than one interface. Exactly. What we are going to do, we are going to define the name of the methods inside the interfaces, such as in talker, say that we have a method with a name talk, and an interface in swimmable, we have a method with a name swim, and inside the human and the dog class, we are going to implement the swim method of the swimmable interface, and which is our responsibility, especially. Then also human class implement another method called which is called as a talk inside the human class. And this is a kind of multiple inheritance, as you can see. And how we can implement it, and we need to learn the syntax to implement this relationship between the classes. And before writing any code, let us learn more further properties of the interfaces. And that's why it is written here is that the interface specifies what operations is going to be permitted the user to perform, but not specify how the operations are performed. If we turn back our example, inside the talker interface, we will just define the name of the method, the action, and the body of this action will be defined inside the human class, and such as suppose that we have a swim method in the swimmable interface, which is an abstract one, and which should be implemented inside both human and the dog class. These are the responsibilities of the given two distinct classes, which are human and dog. And which is the rules, the syntax rule that we need to follow if we want to define an interface. An interface declaration begins with the keyword interface and contains only constant, this is very important, and abstract methods. Which is you can consider interface as a kind of container, which only contains the constant and the method names exactly. And all interface members must be a public, by the way. The access modifier of each constant and the methods should be a public, and by default they are defined as public if it is not specified. And the second property of the interface is given here. The interfaces may not specify any implementation details such as concrete method declarations, exactly method with body, which means the concrete method, and instance variable. Also, you cannot define instance variables within an interface. And all methods declared in an interface are implicitly public and abstract. By default, if it doesn't specify it, all methods are defined as public and abstract. And all the fields are implicitly, whether or not, which means you define it, they are all public, static, and final. And remember that we use the final keyword for defining a constant. We have the static keyword, especially which state that this constant will be reachable by everyone within the class. Also public and another access modifier which allow the other classes access this field directly. Exactly. And these are the rules that we know about it. Especially instead of the class keyword in summary, we are going to use the interface keyword in interface declaration. And goes on. And these are the rules that should be implemented by a given class which use the defined interface. To use an interface, a concrete class such as human or dog must specify that it implements. Actually, this is a resort keyword in Java, implements. And we learned that in order to create an inheritance, we need to use the extends keywords. But for the case of the interfaces, we are going to use the implements keywords, by the way. The interface and the must declare each method in an interface with specified signatures. Especially the concrete class which implements the given interface is responsible to override all abstract methods within itself. Especially the responsibility of the concrete class. In summary, add the implements keyword and the name of the interface to the end of your class declaration's first line. And the class does not implement all methods of an interface, which is an abstract class and must be declared an abstract. And we will look at this point later on when we look at what an abstract class means. And there is an exception in the first rule where if the class is an abstract one and implements some interface, and it doesn't have to override all methods inside the interface, and this is an exception. And implementing an interface is like signing a contract with the compiler that states, I will declare all methods specified by the interface, or I will declare my class is abstract1 especially. And we use the interfaces when disparate, unrelated classes need to be shared common methods and constants, like in our example. Human and dog both are simulable objects, but they are two unrelated classes. And this allows objects of unrelated classes to be processed polymorphically and multiple form, especially polyform, by responding to the same method calls. And this is very helpful feature, by the way, while you are developing a software application. You can create an interface that describes the desired functionality and implements this interface in any classes that require that functionality. And which is a case where we use the code reuse option again. An interface is often used in the place of an abstract class when there is no default implementation to inherit, and that is no field and no default method implementation. Like public abstract classes. Okay, we will skip this point now on and let us continue with an example. And in this example, you will see a simple interface. And let us look at what is going on here. Especially if you look at here, after the public keyword, instead of the class keyword, we see here the interface. And then this is the name of the interface, which is doable. And this is how you define an interface exactly. An interface is a reserved word in Java, by the way, like the class. If we look at the body of the interface, we will see a list of methods names, which are exactly the abstract methods. And if you look at one of the examples here, such as that we have a method whose return type is void, especially, which means that this method will not include any return statement, and the name of the method is do this, and this method does not take any parameter, and the method ends with the semicolon, and you will not see any opening and closing curly braces here, especially the method which has no body. And this is a kind of declaring an abstract method, which is an abstract method declaration. A method without a body means is the following. And you will see that if you look, if you give an enough attendance, okay, if you turn back to the previous slides where we define the rules of the interfaces, and the methods should be declared an abstract methods, but we don't see any abstract keyword in front of the methods declaration. And what does it mean? If you remember, we say that by default all methods within an interface are abstract. Whether or not you define it, it doesn't matter. Also, other methods inside the doable interface does not have any body, as you can see here. Like do this to method with the name do this to has 2 parameters, and then we have another method called the name do the other, and which also takes 1 parameter, and all of them doesn't have anybody, as you can see, and which methods, these methods are abstract one. And these are the next examples that we need to look at, properties of the interfaces. But before this, let me ask you a question. Is there anything for you that's missing up to now? Can you follow the discussion up to now, or if you have any question, please don't hesitate to ask me right now. Static keyword'ü ne anlama geliyordu? Yani esas itibariyle bu değişkenin ya da metodun direkt olarak sınıf içinden çağrılabilmesine olanak sağlayan bir şeydi. Sınıf üzerinden diyelim, içinden demeyelim sadece. Sınıf üzerinden değişken veya metodun çağrılabilmesine olanak sağlayan bir örnek. Mesela bir sınıf içinde sabit tanımladığımız zaman bunu final keyword ile yapabiliyoruz. Ama bunu statik yapmazsak, hayır, onu şöyle, bu bir sabit metodun içinde bir şey tanımladık. Birazdan bir örneğini yaparız. Bir sabit tanımladık. Bu sabiti bir metottan çağırmak istiyorum, sınıf içinde yazılmış. Bunu yapmazsam sabiti ulaşamıyorum, akses edemiyorum. Lokalde kalmış oluyor. Global olarak çağrılabilmesi için static keyword ile adlandırılması gerekiyor. Birazdan örnekleriz yine o. Okay. Maybe at this step we will make an example. And essentially what I want to do is the following one. I want to write a code which makes this job. And let us this example more concrete one. And say that inside the human class, we have additional fields such as, which are the instance variables, say that name, and then whose type is string1, and then say that the other feature that defined on the humankind will be, say that, age of the human. Which is an integer one. And say that inside the Talker interface, we have an abstract method with a name talk. And the return type of this method is the void one. In a similar fashion, we have an abstract method inside the civil interface. And then name of the method is called as swing. And also which has a return type void. And let me turn back our attention to dog class, which is another concrete class. And then one of the fields inside the dog class say that also it has another field called as name. And then whose type is also string1. And then inside the dog class say that we have another field. And then say that, what can I say? The type. And type ırk aslında diyelim bu. Irk neye geliyor? Karşılık. Irk and say that string, which is also a string one. Let me make it boldface. Okay. And then I'm going to create this kind of scenario in Java. Let me create a new project. This is going to be a Java project. Click on next, and the name of the project, say that week 11, say, and click on finish. What I am going to do, create a new package firstly, name the class, and name of the class is going to be a human one. And inside the human class, let me change the font firstly. Okay, I think which is more readable right now. And inside the human class, we have two instance variables: private string and name. And then we have another instance variable called age, but this whose type is an integer one. And that's all. And I will add a constructor inside the human class. How we can add it? Start with the public keyword, call the class name, which is human, open the parentheses and pass the instance variable. And remember, the role of the constructor is instantiating an each instance variable within the class. And then which means that I want to write a constructor which takes two parameters, which are the initial values of the both name and the age variables. Which are some kind of refresher for you. And then we have also another resort keyword in Java called this. Remember, this refers to the object that we work on from this class. Yes, age is integer now. Okay, inside the constructor, you are right. Thank you. Age is going to be an integer one. The name, this dot name will be equal to name, and then this dot age will be equal to age. Okay, this is a kind of constructor. And remember, we can also write more than one constructor at the same class, which means that you can define more than one way to define a human object. Let me do it also there. I want to define a human just with only name. Which only takes one parameter. And then which assign the name of the human to the name given by inside the constructor. And we will also add the getter and setter methods for the both of this instance variable, but we need it because we define them as a private. And to make it more faster, I will get some help from the Eclipse. Go to source tab and click generate getters and setters, and click on the select all and click on OK. And this getter and setter methods for given two instance variables are generated for us. But this is just a small repetition that our work in class define declarations. And now I will continue with the second part of my project. I want to implement two interfaces. But listen, what I need to do, I need to define an interface with a names, talker, and symbol. And inside talker, we have one abstract method called as talk. And we have another, inside the symbol interface, we have another method called as symbol. How we can define an interface? And right click on the package. And from here in this, click on new and go to the interface tab. And click on the interface and give a name to your interface here. And say that which is swimmable, one of them is swimmable. And click on finish. Especially as you can see, our interface declaration is already done by us. And instead of the class keyword, we use an interface keyword in order to define an interface, especially. And then after this keyword, we will continue with our interface name, as you can see. And the name of the interface and the file name are also same. And remember, we said that we can only define the constants and the abstract methods inside within an interface. And say that we define an abstract method. How we can define an abstract method, by the way? Start with public keyword, and after the public, which is access modifier, write here the abstract word. Sorry, not like abstract. And then write the return type of your method, in that case, which is void one, and then name of the method with the parameter list. And since our method will not have any parameter, and we will write as follows, which is the method signature exactly. And the closest method, which is an abstract method, that's why we don't have a body for the given method, put semicolon. And then I can also define another constant here. But now, as you can see, I will delete these two keywords from there, and there is also no warning is given us. Why? If because for the interfaces, all methods by default define as public and abstract, whether or not you define it. But to make it more understandable, I explicitly define them as public and abstract by hand in the first time. Let me say this interface and turn back to our attention to human class. And what I want to do, I want to define my human as a swimmable object. For this case, why I need to make some change here. I want to implement this interface. For this one, instead of the extends keyword, remember we use the extends keyword for inheritance, we are going to use the keyword called as implements. Then after the implements keyword, an empty brace and write the name of the interface. Swimmable. Okay. Actually, by stating this, I said that human is a kind of swimmable object. But to complete this statement, I need to define one more thing. I am responsible to override the swim method inside the human class. And this is the warning given here. The red line under the class name is state this one. The type human must implement the inherited abstract method swimmable swim. Okay, and I need to complete my responsibility here like this one. Either you can click on the source and go to override implement methods and choose the swim method and click on OK. It automatically generate this override annotation for us and call the method signature and open an empty method body. And this is which means that you need to complete this method and turn this one in the complete method. That you need to define the body of the given method. And say that I want to make our job very simple one. I just want to print out some message on the screen as a human. That's why I need to call the system out object and the println method. And say that the name of the human, print out the name of the human, this dot get name, and then can swim. Okay, that's the message that we want to display when we call the swim method over the given human object. And exactly we achieve our first aim. The human class is a swimmable object, and we achieve this statement firstly by stating this syntax human implements swimmable interface, and then we also override the swim method inside the human class. And this is the first part of our job. And remember, we have another class which is very independent and distinct from our human, which is a dog, which represents another kind of object. Let us define the dog class firstly. Dog class is very similar to the human class declaration, but they are two different kind of objects. A dog class will also have some instance variables such as name and the type. And then we will have some constructor for the dog. For this job, to avoid some repetition, I will use the properties of the Eclipse. Click on source. First, generate a constructor by clicking generate constructor using fields. And I want to generate a constructor with two parameters, and which is generated for us, as you can see. And also right here, that's how getter and setter methods for the given two instance variables. Click on source and click on generate getters and setters, select all. Okay, then our job is finished, and you on the outline part you will also see the name of the methods and the instance variables. Okay, what I want to do I want to make the dog also a swimmable object, and I need to state the following statement: implements swimmable. Swimmable. Yep. And I need to override the same method in a way of dog. That I need to write set of statement which is belongs to swimming action of the given dog. And also it will display another kind of message. Say that a dog with name is that name can swim. Okay, we finish our first job here. Our second job, I want to implement another interface with the name talker. We will do the same action again. Right click on new and then click on interface and write the name of the interface, which is talker in that case. Click finish, and then our interface is generated for us. Again, interface talker, and then define the abstract method inside the talker interface. Say that the name of the method will be talk, public, abstract, and then return type is void1, and the name of the method is talk. And then, since this is an abstract method, it doesn't have any body, and a statement will end with semicolon. And I know that the human is both swimmable and a talker object. Normally, in the inheritance concept, we state that a class cannot inherit properties of more than one class. However, a class can implement more than one interface at the same time. And which means that a human class can implement both swimmable and the talker interface as follows. We already implemented swimmable interface, and after that's why we will continue from here. After the swimmable interface name, put comma, and then the name of the second interface will be written. Since I have the same because of the same reason, and in the talker interface there is a method which is an abstract one which is not implemented yet, and as a human I am responsible to implement this unimplemented method, an abstract method which is talk exactly. And also in talk method implement version of the human. Say that I am here since I can think of. Okay, and we complete our scenario where we draw a UML diagram, as you can see there. And we finished our first job. And do you have any questions so far? Is there anything that you want to ask to me right now? Okay. Okay, you ask some question. Let me turn back our attention to this question. And you will see the super reference inside the constructor exactly. Remember that if you doesn't define any constructor inside the super class, and which will automatically, especially if it doesn't define any constructor in a given class, it automatically defines a constructor with no parameter for you. And in that case, this super keyword will refer to the constructor of the object class. Remember that all classes that we define in Java is inherited or originated from one God class. In that case, the God class name is the object one. And to understand the situation, go to the source tab and click on Generate Constructor from Superclass tab. Our superclass is also can be observed here, and this is how the constructor of the given object class is given there. And you will see that we have a superclass, and our superclass is the object one, which is the superclass of all classes in Java, and the constructor doesn't take any argument. And if we turn back our attention to our doc class, and then you will see that this super empty constructor will refer to this constructor of the given object class. And that's why we have the super reference in that class. And we don't have to do it. And you can delete this statement right now. But if you put it there is no problem. It doesn't make any sense. I think that we will use this super reference and by calling the superclass constructor there. And if you want to assign any value which is defined inside my superclass, assigning the initial values of each instance variable which are defined in my superclass. Exactly. The purpose of the statement is this one. But since the object class doesn't have any instance variable, it doesn't take any argument, and this is the empty super constructor call. That's all. Did you get the reason for this, Eren? Do you have any question on this issue? Yani burada yapmak istediğimiz şey şu. Benim süper sınıftaki constructor'ımı çağırmak. Süper kelimesi vasıtasıyla. Yaptığımız bu. Tamam, Batuhan 2'deki derse gidebilirsin. Sorun yok. Tamamdır. Bir ara verelim. Aradan sonra yine bir devam edelim arkadaşlar.